Hello there and welcome. This is the second video in a series about the ICL One Per Desk. What we have here is a British Telecom approved, basically what is these days called a voice modem. There's a modem in here, I think it's 1200 BPS. So you can connect to, I think it was called Prestel in the UK. I'm not so sure, but a dial-up service anyway. And then there's also, there are two lines, which is exceptional for a modem like this. And then there's the handset here from a Spectra phone. So basically with this module and the applications in the Xeon software, you can do everything that this One Per Desk is famous for. You can play back messages using the speech synthesizer, and you have two phone lines. You can do put people through, you can do receptionist stuff using this modem here. But anyway, you could also do basic phone stuff, like what Dialogic became famous for later on, like you know, those press 1 for this, press 2 for that. Okay, so we are in, and basically what we have is the interface to the One Per Desk here, and we have a lot of digital stuff. And we will take a look at that later, but then we have one line interface here that connects to the British Telecom's line. We have another line interface here, and I'm not going to go into detail about modem design in this video here, because basically this is a dead technology. But I used to design, back in the day, I used to design telephone modems and voice modems for all the big players like Hewlett-Packard, Compaq, Packard Bell, yeah, basically all the big ones back then. Dell, Gateway, something with the name 2000 comes to mind. But anyway, if we look at the back, you can see the digital portion here, and it's separated with a huge clearance here, maybe something like 1 centimeter. And then we have two interfaces here. And everything is isolated on the PCB, because British Telecoms had very, very high requirements, even compared to the other European countries. But anyway, what we have is, we have the handset here that comes in the middle here, and there are two relays, one on each side. So you can connect the handset to either line 1, which is over here, or line 2, which is over here. The line interface, I'm not sure you can see it. The line interface has some protection circuits here. There's some Zener diodes and the MOV and some other little stuff here. And that is of course to protect the board from lightning strike and spikes and stuff like that. If you have some lines that are many kilometers long, you will definitely pick up a lot of noise. So that will take care of that. Then we have two or four, we have actually two ceramic modules on each side, and they are quite interesting, I think. I'm not sure why they did that, but they did. And it basically looks like some capacitors on one board, and the other board as well has some capacitors and a little diode. So what that tells me is this little board here, this ceramic module here, handles the line impedance. We have to, of course, to avoid echo and stuff like that, we have to have the same impedance coming into the modem as the impedance of the line itself. So this hybrid module takes care of the impedance. The other module below here, I'm not sure if you can see it. There are some, there's a diode bridge on it, and that is taking care of the DC. Because when you go off hook, when you lift the handset, a little relay here, one of these relays will click, and then you will connect the line, and we will have current going through. And of course that current has to go somewhere, so there's a DC circuit here. Okay, then quite interesting, there's a little 74LS656 down here from SGS, and I haven't been able to figure out what it does, but since it's a TTL gate, it should have 5 volts from somewhere. And it's very unusual to have a digital logic in the analog part here. And that of course needs power from somewhere, and I think that is what this little module is doing here. I'm not quite sure. There's a chip here that I have no idea what's about, and then there's an optocoupler here. So that cannot be it. So that means the 74LS chip here gets power from the line itself. Of course, that's no problem, but I have no idea why they did it in that way. So that is really weird. Then we have the main barrier going through here, and we have read relays here with at least 1 centimeter clearance, and we have transformers from ETAL. And I'm very familiar with ETAL. They used to visit me when I was working in Singapore. And they made some really nice transformers, potted in vacuum, of course, to get air bubbles out, because the creepage and clearance, even internally in the components, were very critical. And yeah, why they have 2 transformers is beyond me, because you can transfer data through there without any problem whatsoever, just using 1 transformer. So it could be that one is used as a switch mode kind of thing, but it doesn't look like it, because we don't have any transistor drivers. So it could be interesting to reverse engineer this board here. But yeah, anyway, I think I'm not going to do that. As I said, modem technology is dead. Nobody's using a dial-up modem anymore. But anyway, we have basically 2 identical and mirrored circuits, line 1 and line 2. And the audio from this line here goes through somewhere. I'm not too sure, because what we have here is the main microcontroller. We have an I/O expander, so this CPU didn't have enough I/O, so we had a separate chip here that could do some parallel I/O. Then on this side here we have an AMD 7910, which is a world chip. This is the modem chip itself. This is 1200 BPS. And there's a little dip switch here. I think using that you can set the modem speed. There's even a little hole in the cabinet here for setting stuff. Here we have the dip switch setting. So we have a line in use and unused dip switch. So we can select which one is the default line, line 1 or line 2. Then we can do a loop disconnect, and that is a way of detecting whether people have hung up in the other end of the line. So yeah, nothing fancy using this. Then on the left here we have all the analog stuff. We have first of all we have a relay driver here, a ULN 2001 is driving the relays, of course. And then we have some analog switches and an op-amp here. So all the audio coming from this side must go somewhere down to here, and all the audio is done over here. Yeah, so a quick little one here about the modem, and the layout is actually, after I look at it, the layout is actually pretty nice, but it just looks extremely messy with all these hybrid modules here. But anyway, very good design, very big relays with a lot of clearance inside. I remember we should have 3mm clearance between anything. So from the coil inside the relay to the contacts in the relay, we should have 3mm at most, as a minimum. And if you do relay design, it's quite difficult to get enough magnetic field to pull these contacts down when you energize the relay. So massive relays here. But anyway, that was my teardown. So yeah, that's it for me. Thank you for watching, and I'll see you again real soon.